Welcome back. Let's practice estimating prices using durations. All right, so here's our first example. We have given that the current price of a bond is $125, the current yield is 6.5%, and the bond's modified duration is 6.98. Estimate the price of the bond using both the first order modified approximation and first order Macaulay approximation if the yield decreases to 6.4%. Okay, so in this problem, we are going to need to use both approximation methods for estimating a new price for a set of cash flows. We need to use both the first order modified approximation and the first order Macaulay approximation. Remember that those are two different approximation methods and they will not give you the same answer, so it's important to remember the differences between the two methods. And so let's start with that. Let's take a look at the formulas for each of these approximation methods. We'll start by looking at the modified approximation. The price of the bond at the new interest rate, I sub n, will be approximately equal to the price of the bond at the original interest rate, I naught, times 1 minus the change in the interest rates, or the new interest rate minus the original interest rate, multiplied by the modified duration using the original interest rate, I naught. Okay, so as expected, the modified approximation involves using a modified duration. Now let's take a look at the Macaulay approximation. This formula is slightly different. The new price of the bond, or the price at the new interest rate, I sub n, will be approximately equal to the original price, or the price at the original interest rate, multiplied by the quantity of 1 plus the original interest rate divided by 1 plus the new interest rate, raised to the power of the Macaulay duration using the original interest rate, I naught. Okay, so once again, as expected, for a Macaulay approximation, we make use of a Macaulay duration. And so those are the two formulas for our different approximation methods for estimating prices. Now let's actually use them, and before we can do that, we need to identify the different values given to us in this problem. So let's do that now. The first thing that we've been given is the current price of the bond. It's $125. So we know that the original price, or P of I naught, is equal to 125. We're then told that the current yield rate, or the current yield, is 6.5%. So that is I naught. I naught is equal to 0.065. That is 6.5% as a decimal. And then we were told that the bond's modified duration is 6.98. So the modified duration at the original interest rate, I naught, or I guess in this case 0.065, is equal to 6.98. And then finally, the last thing that we know here is that we want to estimate the price of this bond if the yield rate decreases to 6.4%. So our new interest rate, or new yield rate, I sub n, is equal to 0.064. Okay, that's 6.4% as a decimal. Now, do we have everything we need to calculate both of these first order approximations? Well, not quite, right? We still need the Macaulay duration using the original interest rate. And so how could we get that Macaulay duration? Well, remember, modified durations and Macaulay durations are related. You might remember this formula. The modified duration for a set of cash flows is equal to the Macaulay duration times a present value factor to the first power. Or another way that we could write that is that the Macaulay duration is equal to the modified duration times 1 plus I, the interest rate for that particular duration. All right, this is the same relationship. It's the same equation. It's just that this one is solved for the modified duration and this one is solved for the Macaulay duration. Well, what we want to use is this right here. We want the Macaulay duration for this bond using the original interest rate of 6.5%. So what we can do is take the modified duration at that interest rate and multiply it by 1 plus that interest rate, and that will give us the Macaulay duration. Okay, so let's do that here. The Macaulay duration at the original interest rate of I naught, or 6.5% in this case, that will be equal to the modified duration of 6.98 multiplied by 1 plus the original interest rate, which is 0.065, so we will have 1.065. Okay, and that's going to represent our Macaulay duration. Now you could plug this into your calculator if you'd like to get the actual value of it, but I'm going to keep it like this for now. I'm just going to put this expression in for that exponent in our formula. Okay, but now we have everything we need to estimate the new price of the bond using both of these approximation methods. Now what we have to do is put the right information into the right parts of these formulas, and we'll be good to go. So let's do that. I'm going to start with the modified approximation. We will have that the new price is approximately equal to the original price of $125 multiplied by 1 minus the change in the interest rates, which is the new rate minus the original rate. So we'll have 0.064 minus 0.065. I'll write that in here. We will have 0.064 minus 0.065, and then we're multiplying by the modified duration using the original interest rate, which is 6.98. Okay, so now you could plug this in your calculator. You could take 0.064 minus 0.065, multiply it by 6.98, subtract it from 1, and then multiply by 125, and you should find that the estimated new price of the bond at a yield rate of 6.4% using the first order modified approximation is $125 and about 87 cents if you round off to 2 decimal places, but if you calculate this yourself, you may find that it only has 2 more decimals after that. It doesn't have a decimal that goes on forever. So if you want to, you can include the full value here. It would be 125.8725. Okay, that is our estimated price using the modified approximation. Now let's move on to our Macaulay approximation. Let's plug in all the information we know. The new price will be approximately equal to the original price of 125 multiplied by 1 plus the original interest rate, which is 0.065. So we will have 1.065 divided by 1 plus the new interest rate, which is 0.064. So we're dividing by 1.064, and then that will be taken to the power of the Macaulay duration at the original interest rate, which we have right here. We take the modified duration of 6.98 and we multiply it by 1 plus the original interest rate, 0.065. Okay, so if you plug this into your calculator, you take 1.065, divide it by 1.064, take it to the power of 6.98 times 1.065, and then multiply all of that by 125, you should find that the new price of the bond is approximately equal to 125.88 when rounded off to 2 decimal places, but we should probably include some more. Since we had 4 decimal places for this approximation, we want to be able to compare these 2 approximations, so let's include some more decimals here. Instead of rounding it off to 2 decimal places, I'll include a couple more here. We have 125.87596 and some more decimals. That is our estimated new price of the bond using a first order Macaulay approximation. So as you can see, they do not give the same answer. They are 2 different approximations. They're very close to each other. They're the same up to the 2nd decimal place, but after that, things do look a little bit different. Okay, and so with that, that is it for this first example. That is how you use the formulas for the first order modified and Macaulay approximations. Let's take a look at another example. Okay, so for our next example, we have a corporate bond with annual coupons is priced to yield 8.2% annually and has a price of $972.48. The Macaulay duration is 8.1245. Using the first order modified approximation, estimate the change in price if rates increase by 0.10%. Okay, so this problem is a little bit different than our previous example. We're still going to be working with one of our approximation methods, in particular the first order modified approximation, but the way that we use the formula for that approximation method is going to look a little bit different. We're going to have to make some slight adjustments to the formula because this time around we're not estimating the price of the bond at a new interest rate. We are estimating the change in the price if the rates increase by 0.10%. Okay, so that's going to require us to calculate something a little bit different than what we did in the last example, but it's actually not too far off. You'll see what I mean as we work through this example. But before we do anything with the formula, before we get into calculating anything, we need to first identify the different values that we've been given. And the first thing that we've been given here is that the corporate bond is priced to yield 8.2% annually. So that is our current interest rate. So let's write that down. I naught is equal to 0.082. That is 8.2% as a decimal. Now, something else that we were told is that the bond's current price, or the price at this percent yield, is $972.48. So the price at I naught, or the original price of the bond, is 972.48. Now, the next thing that we're told is that the Macaulay duration of the bond is 8.1245. So let's write that down as well. The Macaulay duration using the original interest rate, I naught, is equal to 8.1245. And finally, we know one more thing in this problem, and that's that we want to estimate the change in price if the rates increase by 0.10%. That right there is giving us the change in the interest rates. Okay, so what we've been given here is what I like to call delta I, the change in the interest rates. It's equal to the new interest rate, I sub n, minus the original interest rate, I naught. Okay, and in this case, we've been told that that difference, or the change in the interest rates, is 0.10%, which as a decimal is 0.001. Okay, so that's everything that we've been given in this problem. Now what we have to do is make use of these values to help us estimate the change in the price of this bond given this increase in the yield rate. And so remember, we're going to be making use of the first order modified approximation. So this is the formula we're going to make use of. The new price of the bond, P of I sub n, is approximately equal to the original price multiplied by 1 minus the change in the interest rates, but I'm just going to represent that with delta I, multiplied by the modified duration at the original interest rate, I naught. Okay, so that's the formula we used in the previous example. It should look familiar, other than the fact that I changed this right here to be delta I. But we're not interested in estimating the price per se. We want to estimate the change in the price. So how do we do that? Well, what we can do is slightly modify our equation here. And in order for you to see how we're going to do that, first I want to distribute this original price through this quantity. We're going to multiply it by 1, then multiply it by negative delta I times the modified duration. So if we do that, we're going to have P of I sub n is approximately equal to the original price times 1, so it's just the original price, and then we will have minus the original price times delta I times the modified duration using that original interest rate. Okay, now the reason I did that is because now we can subtract the original price from both sides of this equation, or I guess you could call it an approximation, not an equation. However you want to view it, we're going to subtract the original price from both sides regardless. We're going to have the new price minus the original price is approximately equal to the negative original price times delta I times the modified duration using that original interest rate. Okay, and what we have here is how we can estimate the change in the price. Because right here, we have the change in the price. We have the new price minus the original price. That represents the change in the price. Another way that we could refer to that is with delta P. The change in the price is equal to the new price, P of I sub n, minus the original price, P of I naught. Okay, if you watched my lesson video on this topic, that should look familiar. So, to estimate the change in price, we just need to take the negative original price times the change in the interest rates times the modified duration at the original interest rate, and we have all of those values except one, right? We have the original price, we have delta I, but we don't have the modified duration. We have the Macaulay duration, but we don't have the modified duration, so we will need to convert that. And if you watched the previous example, then you should remember that the Macaulay duration and the modified duration are related. We can easily convert between the two. Remember the relationship that the modified duration is equal to the Macaulay duration multiplied by a present value factor, which in this case we would just be multiplying by 1 divided by 1 plus that original interest rate, I naught. Okay, so let's do that up here. Let's calculate the modified duration at the original interest rate. It will be equal to 8.1245 multiplied by 1 divided by 1 plus the original interest rate, which is 0.082. So we will be dividing by 1.082. Okay, and I'm just going to leave it like that. You could plug that into your calculator if you wanted to, but I'm just going to use this as the value for the modified duration in this estimation. All right, so now let's work on that. We want to calculate our estimated change in price. I'm going to do it right here. Our change in price, which is just this expression right here, the new price minus the original price, that will be approximately equal to the negative original price, which is right here, $972.48, multiplied by delta I, which is 0.001. So we'll multiply by 0.001, and then we want to multiply by the modified duration using the original interest rate, which we have right here. And I'm going to write it like this. We'll be multiplying by 8.1245 divided by 1.082. Okay, and so if you do this in your calculator, if you perform this calculation, you should find that the change in the price is approximately equal to negative 7.302 and some more decimals. That is the final answer to this example problem. What we have just learned is that if the rates increase by 0.10% for this corporate bond, we are estimating that the price would change in the negative direction by $7.3. Okay, in other words, the price will decrease by that amount. That's what we would expect. That's what we're estimating will happen based on a first order modified approximation. Okay, and I really want to stress that we needed to use the modified approximation here because the problem told us to use it. Even though we were given a Macaulay duration, that does not mean that you can just use the Macaulay approximation instead. You have to use the approximation you were told to use. And so if you're given the wrong duration, you need to change it to the correct duration using that relationship between a mod D and a mac D. Okay, let's move on to our last example for this video. Okay, so for our third and final example, we have Ezra is receiving payments from an annuity due that uses an annual effective interest rate of 5% and has a present value of $135,000. Ezra uses the first order Macaulay approximation to estimate the present value of his annuity due at an annual effective interest rate of 5.3% to be $133,038. Find the modified duration of Ezra's annuity at 5%. Okay, so this problem is giving us a little bit of a different task than the previous two examples. Notice that in this example, we have already been given the estimated price at the new interest rate for Ezra's set of cash flows, or more specifically, his annuity due. Right? We are told that he uses the first order Macaulay approximation to estimate the present value of his annuity due at this new interest rate of 5.3%, and that estimated value is $133,038. So in this problem, we're not going to be interested in calculating the estimated price or present value, or even the change in the present value or percent change in the present value. We're going to be finding something else with the help of that estimated present value. In this case, we are going to be finding the modified duration of his annuity at a specific interest rate. And that interest rate also happens to be the original interest rate of Ezra's annuity due. All right, so let's write down all the information that we've been given here, and then we can discuss how we're going to calculate that modified duration. And first off, we know that his original interest rate is 5%, so that's I naught. So I'll write I naught is equal to 0.05. That's 5% as a decimal. We know that the original present value at that interest rate is $135,000. So the price or present value at the original interest rate is $135,000. And we're told that he uses the first order Macaulay approximation to estimate the present value at the new interest rate of 5.3%. So we know that I sub n is equal to 0.053. That's the new interest rate. And the new price, or the new estimated price, I should say, P of I sub n is equal to $133,038. Now, what we don't know in this problem is the modified duration. That's what we want to find. Okay, so we want to calculate the modified duration, or the mod D, at the original interest rate of I naught, right? We want to find it at 5%, which is the original interest rate. That's what we don't know in this problem. That's what we need to find. And so how are we going to do that? Well, we have to use the information that we've been given here. In particular, we need to use this estimated present value, but we need to know where that came from, right? Which approximation method did Ezra use? We can't mess this up. We can't use the wrong approximation method or our answer will be wrong because the two approximation methods are different. In this case, Ezra uses the first order Macaulay approximation. So this is the formula we need to work with. The new price is approximately equal to the original price multiplied by 1 plus the original interest rate divided by 1 plus the new interest rate, and that is raised to the power of the Macaulay duration at the original interest rate. Okay? You can't just stick the modified duration there because that's what we want to solve for. This is the first order Macaulay approximation formula, so you have to use the Macaulay duration in that exponent. That is just the way the formula is. Okay, so it looks like what we're going to have to do here, since we know everything in this formula except the Macaulay duration, is we're going to have to solve for the Macaulay duration and then convert it to a modified duration using that relationship formula that we have used in all the other examples of this video as well. Okay, it's really important for you to know how to switch between a modified duration and a Macaulay duration because in these types of problems, you're most likely going to have to do it at some point or another. Okay, so let's work on solving for the Macaulay duration. Let's fill in this formula with all the values that we know. Before I do that, I should make a slight adjustment here. Since this is an estimated present value and not the actual present value at the new interest rate, we technically don't need these approximation signs because that estimated present value would be equal to this. So this is kind of a weird situation where we can put an equal sign here in this formula. So we're going to have 133,038 is equal to 135,000 multiplied by 1 plus the original interest rate, which is 0.05. So we'll have 1.05 divided by 1 plus the new interest rate, which is 0.053. So we'll have 1.053. And that will be raised to the power of the Macaulay duration that we don't know. Okay? That's what we need to solve for. So let's start working on that. It looks like it's going to be a little bit tricky at the moment, but it's nothing that we can't do. First thing I'm going to do is divide both sides of the equation by 135,000. Our goal here is going to be to isolate the Macaulay duration, but before we can even talk about doing that, we need to get this constant multiple on the other side by dividing both sides of the equation by it. So let's continue our work up here. We'll have 133,038 divided by 135,000, and that's going to be equal to 1.05 divided by 1.053 to the power of the Macaulay duration. Now, do you remember how we can solve for an unknown exponent? Because that's what we have to do at this point. We have an unknown exponent and somehow we have to solve for it. Well, the way that I like to go about it is by introducing a logarithm, in particular the natural logarithm. That's what I like to use at least. Technically, you could use any logarithm you'd like. They all have the same property that we're going to use here, but the natural log I find is the easiest to work with. It's the simplest to write. So what I'm going to do is take the natural log of both sides of the equation, and then we'll talk about what that does for us. So I'm going to take the natural log of both sides of the equation, and what that allows us to do is actually move this exponent of the Macaulay duration outside of the logarithm. We are making use of a logarithmic property that the natural log, or really any logarithm, of a to the power of b is equal to b times the natural log of a. You can take an exponent of a value inside a logarithm and bring it to the outside and multiply it by that logarithm, leaving the original base inside the logarithm. So here's what we're going to have in this case. The natural log of 133,038 divided by 135,000 is equal to the Macaulay duration at the original interest rate times the natural log of 1.05 divided by 1.053. Okay, we just took that exponent of this quantity inside the natural log, brought it outside, multiplied it by the natural log of that same base, and now we can actually solve for that Macaulay duration by dividing both sides by this logarithm. Okay, so here's what we're going to find. The Macaulay duration of the original interest rate, or the Macaulay duration evaluated at that original interest rate, will be equal to this natural log divided by this natural log. So it's going to look like this. We'll have the natural log of 133,038 divided by 135,000, and that natural log is divided by this natural log of 1.05 divided by 1.053. And if you plug all that into your calculator, you should find that the Macaulay duration is equal to about 5.1313 and some more decimals. But that's not our final answer, right? We don't want the Macaulay duration at the original interest rate. We want the modified duration at the original interest rate. And so in order to get that modified duration, we do need to convert the Macaulay duration to a modified duration. We can do that by multiplying by a present value factor using the original interest rate, right? Don't forget, a modified duration is equal to the Macaulay duration of the same set of cash flows, of course, multiplied by a present value factor. So in this case, our final answer is that the modified duration at the original interest rate is equal to our Macaulay duration of 5.1313 divided by 1 plus the original interest rate, which in this case is 0.05. So we're dividing by 1.05. And if you do that in your calculator, you should get that the modified duration at 5% for Ezra's annuity is equal to 4.89 and some more decimals. That is the final answer to this example problem. 4.89 is the modified duration at 5% of Ezra's annuity due, given that his estimated present value at 5.3% is $133,038. Okay, and so with that, that is it for this example, and this was also the last example for this examples video. However, I do have 2 more example problems available on my membership site, JK Math Plus. So if you do want some more practice estimating prices using durations, feel free to look into becoming a member. You can learn more about my membership site on my website at jkmathematics.com/plus. So feel free to check that out if you're interested. There's a whole lot more on there than just those 2 extra examples. There's extra examples for other topics in financial mathematics, as well as a lot of extra review problems for my unit review videos that you can find in my FM playlist. All right, those review videos have extra examples that are exclusive to the membership site, so that's something to keep in mind as well. There's a lot of exclusive bonus content for you to enjoy if you're a member. Okay, so once again, feel free to head on over to my website if you want to learn more about the membership site. But with that, that's all I had for this video. So if you have any questions, please leave them in the comments below. But if you don't have any questions, this is all I had for now. So I will see you next time.